Hi, everybody. My name is Bob Fay. I'm the Houston Regional Manager, and I'd like to thank everybody for coming to our webinar, our training webinar. I know we have people from all around the world, and some people are up late, some people are up early, so we really appreciate you attending. And to my left, of course, is Trip, who I'm sure most of you know. So I'd like to let Trip talk about himself or tell us about himself and what we're doing today.
Hey guys, like Bob said, my name's Trip. I'm the business development manager here at Excell Battery. Bob and I have wanted to do this webinar for a very long time because we have so many questions that constantly get asked. And we thought we'd put it down on paper and put it in a webinar to you. I said, just to be totally transparent, we're not trying to copy David Gibson because he does such a great job at the V door and locksmith, and of course the Gibson reports. But this is our stab at it. With all that being said, I'd like to start with a list of questions I'm going to ask Bob. As y'all know, he's been doing this for over 35 years, so all this comes to him very second nature. And so we'll get started with that. But also, there's a place where you can actually add your questions. They will be anonymous. And hopefully we can get to those at the end. And we probably are going to cover most of what you're going to ask anyway. So to get us started, I'm going to work through the Criterion gauge first, and then I'm going to talk about or ask questions about the battery itself. And I guess we could just get started.
Yes. One thing about the questions, there's a Q&A button link on your screen. So just click there and type your question, and we'll see it here.
All right, let's do it. So what does the Criterion 4 measure?
Well, Criterion 4 measures a lot of different things, including time of day, pack voltage, peak and average current, temperature, 3-axis shock and vibration, and rotation. And it uses that information to calculate stick slip and capacity use.
Right. Explain how we measure shock and vibration and how accurate are these measurements?
Well, we have an accelerometer on the gauge on the PC board inside the battery, and it's going to measure 3-axis shock and vibration. It will measure up to 140 G RMS in the 140 G RMS and up to 200 Gs of shock. The accuracy, it's plus or minus 10%, so it's pretty accurate, and is pretty remarkable considering it's just a small little chip inside the battery. But as you can see on the screen here, we're showing a example of the EBL file that we call it that shows how the shock and vibration is displayed in the app.
In addition to that, we have rotation and stick slip. Could you cover some of that?
Sure. We have a magnetometer on the gauge, and it will measure rotation, like how fast the battery is rotating around magnetic north. And it could measure up to 500 RPM, and it is accurate plus or minus 5%.
How is stick slip calculated?
Well, stick slip is actually using that rotation information, and it is a ratio of the difference between maximum and minimum rate of rotation to the mean rate of rotation. And it's shown in the data as a percentage. The brown line that you see on the screen is how it shows up in the app. So it could give you an idea of just how rough, how things are not as smooth as probably you want it to be.
So what's the sampling rate for the shock and the vibe and the rotation?
Well, the different measurements will measure at different things. So shock and vibrations measuring 800 times a second, the rotation 1,000 times a second, and current 1,000 samples per second. So combined, this is giving you a very, very detailed view of what's going on downhole with the battery. So we're pretty much able to capture everything that is happening down there and display it to you in the app.
A big question that always comes up is energy consumption. What is the gauge actually consuming of the battery?
Well, of course, it doesn't come totally free because the gauge is a processor and it requires power to operate. But we have been able to reduce that to a very low number. So when we ship the battery to you and when it's actually not being used, it's in deep sleep. So it's using about 200 microamps. When it's actually awake and logging and recording, it's using more current, of course. It's using about 5 milliamps. But a recent change that we have made to it is to reduce the consumption after you receive it. We used to have 2 different sleep modes. Now it is just using deep sleep, 200 microamps when it's not actually awake and recording.
How long does it take to download?
Well, that really depends on how much, how you set up the logging interval. So the more information you're logging, of course, the more data is in there. So it's going to take longer to download. But we actually in the app have a tool to help you understand just how long it's going to take. That arrow is actually pointed to the wrong place, but that white box to the lower right of that arrow shows you how long it's going to take to download based on the login interval that you set up. So after you set it up, depending on how much stuff you're trying to record, you can get a good idea how long it's going to take you to download after the job is over.
Sometimes we send out our gauge and it doesn't get programmed by the client. What happens if it's not programmed?
Well, if you do nothing else, it's going to record how much capacity you use. So it's going to measure the current in the background. And then when you bring it back in the shop and hook it up, it's going to write that information in memory. So you at least will know just how much capacity is being used in the battery. So if you mess up and don't set it up like we tried to show you how to do, it's still going to tell you how much capacity you use in that battery.
So as you know, we have 2 versions. We have a power line modulation we call PLM, and then we have CAN open. What's the difference?
Well, if you can bring up the next slide there, it's a very crude drawing of a battery pack with the next one. A very crude drawing of the battery with a gauge. Kind of looks like a stick figure, doesn't it? But anyways, on the left is what we call the CAN version, and that's the original version that we had, where it has 4 wires to connect to the outside. So you have a battery plus, a battery minus, CAN high, CAN low, and uses 4 wires on the battery. We have found in some cases, there's some tools out there that actually are on the same lines as those CAN high and CAN low lines. And there could be some signal interference causing issues with either the gauge or the tool. So we developed what we call the power line modulation version on the right, which only has 2 wires. So we're getting all the information through the battery plus line and the battery minus line, eliminating extra wires that are not needed. This also allows us to go into batteries, or the gauge to go into batteries that maybe only have 2 lines available, such as applied physics. They don't have a whole bunch of different wires like the regular old tensor battery has.
So Criterion gauge, a lot of folks ask, what is our maximum operating temperature?
It's at 165C. We've tried to go a little bit higher than that, but it wasn't as accurate. So we say 165C is our max temperature rating. However, we are working on a 180C version, and hopefully it's coming soon.
Hopefully. Can't wait for that. It's very exciting.
Yes.
If the Criterion stops working, what does that do to the battery pack?
Well, the battery does not need the Criterion to operate. So if the Criterion, for whatever reason, or you don't program it correctly or whatever, it's still going to discharge normally. It'll discharge through the Criterion gauge. So the tool will still get all the current that it needs as if the gauge wasn't there. So no effect on the performance of the battery.
Mike McWillie and the gang are always working on new improvements. Our group in Vancouver. And could you kind of elaborate on what's coming down the pipe with
Sure.
CR5?
Of course, Mike McWillie is our engineering director in Vancouver, and he's basically the father of the gauge. So yes, we are working on a new version, an upgraded version, CR5. But we're going to keep that information to our chest for now. So we'll hopefully be announcing this soon. I'm not sure when, but CR5, we're always trying to move ahead. We're trying to make something better. So the CR5 is on the horizon.
What's your feeling about reusing a Criterion gauge?
Well, we get asked that a lot. Can we take the gauge out and reuse it? Well, that involves taking the battery pack apart, cutting the fiberglass tube open, cleaning it all up, and try to reinstall it. It just takes too much time. There's a lot of effort to do that. Maybe a bit of a safety issue, obviously. So we do not reuse the gauge.
Well, that's it for the Criterion. We're going to move on to the actual battery pack, and we'll start with how long will my battery last?
Well, that's a question we get asked a lot, and it's very difficult to answer just with that type of question. So I'm bringing up my chalkboard here to show you how you can figure out how many hours the battery will last. So you know, of course, or we tell you it's on the battery, it's on whatever, the spec sheet. The battery has a capacity in amp hours. So you simply take that number divided by average current, and that'll give you how many hours it will last. So 20 amp hour battery, if it's using 150 milliamps or 0.15 amps, it's going to give you 193 hours. Of course, that is average current over the whole lifetime or the whole time it's being used. So don't count just peaks or valleys in the current. Take that average current, and that'll give you how many hours.
We get asked often about temperature ranges of our battery packs. And sometimes folks are asking, do you make a 175? And they're mainly saying that because the tools that they're using are sometimes rated to 175. Can you kind of expand on the different temperature ranges that are available in a battery pack? MWD pack.
MWD pack, right. MWD batteries are basically high temperature batteries. There's 4 different basic temperature ratings available: 150, 165C, 180, and 200. The 165 is by far the most popular. Most of the batteries out there utilize 165C rated cells. So that's, what you mostly see out there.
And there's different versions of this cell. We have high rates and moderate rates. When do you use one over the other? How is the construction too?
Sure. We'll talk a bit about that. By the way, please ask the questions. I'd like to see some more questions here, which we'll answer here in a few minutes.
And they are anonymous.
Yeah. Unless we know that person, we'll call them out. But, okay. So there's 2 basic types of cell constructions that are used in downhole batteries: moderate rate and high rate. What's shown up on the screen now is moderate rate, and this is by far the most common version. It has a lot of advantages, and it's been optimized and actually initially developed for downhole drilling. So a moderate rate is medium rate. Now, it's built this way. Well, first of all, the current capability of a cell is dependent on how much surface area between the electrodes. So the area between the lithium anode and the carbon cathode determines how much current that cell can put out. So a moderate basically has 2 layers of lithium surrounding 1 layer of cathode. So it gives that much surface area to give a pretty good amount of current for most MWD tools. The photos on the right are actual photos of cells being manufactured. So that silvery gray looking thing is the lithium. And of course, you can see the person wearing a glove as they handle it, because if they weren't wearing a glove, you're going to get real hot spots and black marks and corrosion. And it could be dangerous if they held onto that with your hand, because your hand has moisture. Anyway, kind of digressed there, but the layers of lithium are surrounding that black carbon cathode that you see inside the white separator paper area in the bottom photo. So moderate cells give out medium current in relation to the next slide, which shows high rate or spiral cell. And that is basically a cell that has a winding of really long, thin electrodes. They spiral up into what some people call a jelly roll spiral construction. So it gives it a lot of current, probably 2 to 3 times the amount of current from a moderate cell. Spiral cells, because they have so much current capability, they do have to be fused. There's an individual fuse on each cell, unlike a moderate cell, which is designed to withstand a short circuit at room temperature so it doesn't have anything bad happen to it. So those cells do not have fuses. So some people could call that a disadvantage, having fuses everywhere, but they're obviously needed for safety. But spiral cells are generally used in EM tools, high current applications. Moderate cells are used almost everywhere else with a regular MWD type application.
Of course, with that comes the amp hour ratings. What is the span?
Right. So the next slide does show some different ranges. The double D high rate 150 are generally around 28 amp hours. 165 are about 21, 22 amp hours. And then the 180C high rates are generally about 15 amp hours. The most common one out there, the double D moderate 165 are about 29 amp hours. And double D moderate 180 about 24. You probably don't see a double D moderate 150 in this column or this chart, mainly because there's really no difference. There's no difference between the 150 and the 165 moderate. So years ago, we just decided, okay, well, we don't really need a 150 moderate because it does everything the same as a 165. So that's why it's missing.
So with the different temperature ranges, once you shift from 165 to 180 and 200, of course, explain the difficulties that you run into when you make that jump from a 165, let's say, to a 180, mainly 180s, but there are 200s.
Right. Well, 180 is most common for the higher than 165. Well, 165 and below, everything below that uses a lithium anode made of 100% lithium metal. When they make a cell or battery capable of 180C, they're alloying the lithium with magnesium. So there's a mixture of lithium, mostly lithium and magnesium. So the more magnesium they put in it, the higher the temperature rating of the cell. Basically what they're trying to do is raise the melting temperature of lithium at a higher point so that it doesn't melt down and explode in the worst case. So that magnesium in the alloy works against you where it doesn't have the current capability of a 165 or 150C rated cell. Also, the passivation for 180 and 200 is a bit different, a bit more intense. So 180 and 200Cs require a bit more preparation, a bit more work, especially if the temperatures are cold when you start using them. So you basically need to have the battery at room temperature or above to get any good performance out of it. We usually get calls in the winter, when it's, below freezing, 0C or whatever, where 180Cs are just not working as well. Well, the answer is, put it into a warm room or put it in the sunlight to get it to work. Depassivation is a bit more difficult with those. So just make sure you warm it up to room temperature first. One thing about that, never use heat to depassivate a battery. Never use heat to depassivate a battery. That's where bad things have happened and can occur, mainly because the heating device may not be as reliable or whatever. Just don't rely on a heating device to depassivate a battery. So just remember that, please.
Absolutely. What's the maximum temperature of a battery?
Well, that depends on the cell. The cell is the driver for temperature rating of a battery. So a 150C cell, we make a 150C battery.
Is there any fudge?
No fudge. No fudge. People ask that a lot. can I take my 165 battery to 170? Well, the answer is no, because even though the melting temperature of lithium is a upper limit far as when a battery may explode, there is some temperature between there that if you get into that above 165, you may cause a leakage and such that could be pretty bad too.
So we put fuses in the batteries, in the packs. And could you explain where we actually place them throughout the battery?
Sure. All batteries will have at least one fuse. And it's usually, in most cases, accessible on the outside. When we add the CR4, we add a second fuse, mainly to protect the battery stack from the CR4 itself. So this is a rough diagram of maybe a tensor battery where there'll be a 7 amp fuse on the inside between the cell stack and the CR4. And there's going to be another 5 amp fuse on the outside. A regular traditional tensor battery that'll be in the pigtail. Other batteries with MDM to MDM type connections, the 5 amp fuse will be installed in the end piece. In most cases, not all, but most cases, that 5 amp fuse is user accessible and replaceable. So you don't always have to send it back here for replacement. One thing this slide is not showing is that if there's a high rate battery, those cells will contain individual fuses. So that, I think there's 9 cells in this drawing here.
All high rates.
All high rates will have cells on the fuses as well. We will not put that 7 amp fuse in a high rate battery, but there will still be a fuse on the outside.
One of the ugly things of our business is a vented battery. How do you handle it?
Well, a vented battery, exploded battery, or a battery housing that's been cracked open or whatever from an explosion downhole should all be pretty much treated the same way. And that is, call us up, number one, and we'll talk about it with you. But the only way to dispose of the battery or to transport it off your site is to get what we call a PG1 box, packing group 1 box. Looks like this in the picture. It's a big, heavy wooden crate. It contains vermiculite in a big old plastic tube in there that you can stick the housing into. But this is the only acceptable legal method of doing this now. There used to be other ways, but now, today, we have to use these PG1 boxes. We have access to these things at different lengths, depending on how long the tool or battery is that you need to dispose of. Hopefully we can accommodate whatever length you come up with. But we can get that to you.
Will water damage a battery?
This is a question a lot. If I pour water on my battery, is it going to blow up or is it going to catch on fire? Well, really talking NWD batteries, because they're almost always encapsulated in a fiberglass tube with ends epoxied onto it. The battery is basically waterproof at that point. You spill water in a fiberglass tube, it's just going to run off. Lithium is very reactive to water. Yes, it will catch on fire with water. But to get to lithium inside your battery, you basically need to cut open the battery, cut open the cell, pull that lithium out, and pour water on it. So that's a pretty difficult thing to do and dangerous. Don't do it, please. So just simply getting water in your battery, no big deal. If you think there's water damage, yeah, maybe not use that battery anymore, but water is not going to be in itself a safety hazard.
How do we dispose of just regular depleted batteries?
We use a couple different companies in North America, and they both end up crushing, shredding the battery. So they have their process. I know you're probably thinking, wow, shred a battery? Well, they have processes where they freeze it, make it inert, safe, and they crush it up, and then they extract some material, mostly the lithium. They'll actually recycle the lithium and use it somewhere else. The rest of the stuff is just neutralized and mostly landfilled. But one thing about lithium thionyl chloride batteries is they're a very green battery. There's no long-lasting contamination. Yes, they're reactive, but once you neutralize and break it down, very clean.
Do we ever save and reuse parts?
No, just like the gauge, it's not worth it. It's a lot of time, a lot of effort to clean them up for parts that really are costing that much money. So no, we dispose of the whole thing.
Something, we've been pretty active in is our safety training, and how do we offer that to the clients?
Sure. We have safety training available to anybody. We can either come to you and do a face-to-face training, or we could send you the PowerPoint presentation. But we now have the safety training on our YouTube channel. If you scan this, we'll leave it up for a little bit. If you want to scan this, we'll take you to a link to our YouTube channel where you can follow the same PowerPoint presentation as we give it. So we do have questions. People have been asking.
Awesome.
So, I just lost my question.
Oh, dude.
Okay. So, share it here. So, I guess there was a question given to us earlier when we were talking about the, max temp of the gauge. That's a sustaining temperature. So you should be able to use that at 165C sustaining. Maybe you can go, I'm not going to say it, but we say 165C. You want to read this off?
Sure. So what is the shelf life of a new battery pack?
That really depends on how much capacity you want to lose, over the time.
Does it have a gauge? Does it not have a gauge?
Well, that's two different things. The shelf life of a battery pack depends on the self-discharge rate. So lithium chloride cells are considered to have about a 2 to 3% capacity loss per year. So the shelf life really depends on how much capacity loss you can afford. So after 10 years, you've lost 20% or 30%. So if you feel that that's still usable, well, that's the shelf life, 10 years. But that's in the past has been the accepted number, 10 years. But I've done testing of cells that are more than 10 years old and they actually work fine.
Or even less than what you were saying.
Less. Right.
2% a year.
As long as they're stored nicely and,
right.
Air conditioned area, they should be good to go for many, many years.
Well, that brings up the next question. It's how should a battery be stored? Vertical, horizontal, and at what temperature? Good question.
Storage, vertical, horizontal doesn't really matter so much. That could be applied to discharge. If you discharge a battery vertically where the cells are considered upside down. No, I got that wrong. If the cells are vertical straight up, they may have a little less capacity because the way the electrolyte wets the electrodes on the inside, but storage, it doesn't matter. Temperature is a big thing. It does matter. We recommend you keep them at a comfortable room temperature, like where you want to be. In other words, in the summer in Houston, keep them in an air conditioned facility. Don't store them in a shed in the back in the sun, because that will cause more passivation, higher self-discharge. So definitely keep them in a cool area, like where you want to be.
Next question. You mentioned that a battery can last 28 amp hours, but I have worked with batteries that run at 13 to 16 or 17 amp hours. These were manufactured in 21 with normal use, where with the same data, others have been depassivated in 20. Why is that? What can we do to minimize that or have more from the battery? It's something about storing it.
So, yes, the batteries are rated for a certain capacity, 28, 29 amp hours. I don't think, based on what MWD tools draw current from the battery, at that level, which are usually much higher than the battery's actually rated for, that's going to set capacity. 28 amp hours may become 26 amp hours. I think that's what we've seen in tensor batteries, typical tensor. Even though it's a 29 amp hour rated battery, most people get about 26. And the reason for that is the current being drawn from the battery is actually more than what the moderate cells can actually do. So that affects the capacity in a negative way. Maybe a spiral cell will give you a bit more capacity, but generally the capacity can be reduced with very high current rate.
Do we purchase cells with gallium in it?
Well, gallium is a additive salt that's used in thionyl chloride batteries. Every moderate cell out there in the market contains gallium. Spirals don't always contain gallium, but gallium trichloride is added to the electrolyte to help reduce passivation. By the cell manufacturers, we don't do that, of course, but yes, all the moderated cells that we have contain gallium.
For the log data, are they all averaged over the logging interval? Is peak the only exception? Or is there any other data that takes max value per logging interval?
In the CR4 data, there's two current numbers that you see. There's current, which is average current, that it sees over the logging interval, and it also sees peak current. And peak is the highest current that it saw in that logging interval. So if your logging interval is set up for 5 seconds, it's going to take 5,000 readings. So current is the average of those 5,000 readings, and the peak is the highest current that it saw in those 5,000 readings.
Next question is pretty important, and we encourage it, is to depass a battery before it makes a run. And they're asking, does that help the performance?
It definitely helps the performance, especially on startup when you actually start using the battery. What you're trying to do is I'll just back up a bit. When a cell is first made, when electrolyte is poured into the cell casing, passivation forms immediately. What this is a very high resistance layer between the anode and the cathode to prevent it inhibits the discharge into what you see as a low voltage. So what you're trying to do with depass is to remove that layer to allow the battery to discharge more efficiently. So if you were to take a very passivated battery and put a load on it, you're going to see that voltage drop down and eventually come back up. So a depass procedure is trying to get yourself past that voltage drop to where it's a stable voltage. So it's a very important thing that everybody does before they actually use a battery. You can do it on the surface in your shop, and it should last for a while before you have to worry about it again. A couple weeks. It really depends on a lot of factors, but if you depass it, send it out to the field, you should be good to go. But it is important to depass a battery.
It should be SOP and the Criterion, it shows whether it's been done or not.
That's actually a question that came up this morning elsewhere. The interface box that is for Criterion is also a depassivation unit. You can use that to depassivate your battery. And you could actually use it on a battery that does not contain a Criterion gauge, as long as you have the right cable to attach to the gauge.
And you can set your own resistance.
That's right. Yeah. That's right.
Do you know why we are able to connect to the battery through a JAE SDM and download the EBL files sometimes, but not all the time?
Unfortunately, I know JAE, but I do not know the reason for this. It's, I'm sure we could work with them to find out how the connections are, but as long as they're able to connect to the CAN lines, I guess you could do it through the JAE. I don't know. As long as you can get access to those CAN lines, you should be able to download the data.
Please phone.
Yes.
How dangerous is bypassing the 5 amp fuse?
Well, we definitely do not recommend that. The 5 amp fuse is there for your protection. It's there to prevent a short circuit from heating up and possibly causing the battery to explode. So without that 5 amp fuse, you short circuit the battery. It's not a good thing. At a minimum, you're going to see battery, the cells heat up very, very hot. So there should be no reason to bypass that fuse.
Another question is on the PG1 boxes. That's usually billed to the client. And so if you want to have boxes on site so that you're ready to go, that's great. And no, you don't have to just come through us. We don't add anything to it. So if you want to go direct, we can certainly give you a phone number to call, but we want to be a service. So not only are we providing the box, but many times we'll be on site to be there to make sure everybody's following the proper procedures, because it is a vented battery. Things can happen. So we want to be as safety conscious as possible. Where do the disposal batteries end up?
One of the companies we work with is in Trail, British Columbia. They do the processing there. Not really sure where the residual stuff ends up after that, but that's one of the main processes that are for batteries in North America.
Is the lithium reusable? Well, they're reusing it.
They actually extract the lithium,
Right.
but it's not being used in batteries at that point. It's a different form. I mean, lithium is used in many, many different products, not just batteries, but I guess golf balls used to use it at one time. Titleist, lithium sterling cover. There used to be a marketing thing they had. So maybe stick a probe in a golf ball and might power something.
You mentioned the onboard electronics aren't as good as at higher temps. Just curious, is this electronics recover as temps cool?
I would say so. Our biggest concern with going over the temperature is the accuracy of the components. If the PC board actually gets affected by heat, then obviously that's not going to recover. So, it really depends on how high you go.
When a battery comes back from the field and on the bench it's hot to the touch, that's not good.
Well, I guess it does depend on how recent it came out of the hole.
Well, surely it didn't.
But if it's back in the shop, it should be cool to the touch. So if there is
doghouse on location or something.
If there is heat coming from that battery when it's in a shop, there's a very good indication there's a short circuit going on.
Okay. My question will be timestamp related. In case date and time set as ahead of current date, it's mistakenly due to wrong region, etc. It's just, in this case, Criterion doesn't allow us to start logging with the updated date and time, which is back, but current one from the first. Can we make overlap date and time logging sessions on different record partition memory? Good question.
That's a very good question. And we actually see who this is. So I think we should reach out and talk about that.
These are our friends in Turkey.
Yes. But, I'm not sure. I don't know if I have the answer to that one right now. The app does give you the ability to stop the logging and reset the clock to current time if it's off. Just like any processor, it will drift over time, but the app gives you the ability to bring it to current time. I think we probably went up to our time here, so we have some other questions here. Let's see. Let's look back here. A lot of really good questions for you. But I think in the interest of time, we're gonna wrap it up here. And I think what I'm going to do is we're going to make a list of these questions available with answers, and we'll distribute them to the group here. So there's some very good questions. I really thank you for doing that. And anyway, anything class to say?
Well, thanks a lot. And we hope to do this again on different subjects, but I appreciate your time, especially folks that are on this, the world is bedtime. Sorry for keeping you up, but hopefully it was informative, and we look forward to seeing you in person again. But until then,
All right. Well, thank you. And please call us if you have any other questions that are specific, and we'll see you soon.